Hi, everybody. This is an ad hoc meeting of the work group device management. And we're going to talk specifically around end user and cluster platform administrator type of use cases with Abhishek and others but in particular, try to get his feedback on these type of things. So what I wanted to start with, we have, let me share this. I'm just going to share this whole. For now, I'll share this whole window. So we have this document around gathering the use cases. And so we're going to need to, I think that some of your use cases, Abhishek, came in through the workgroup serving. But I'm just going to, actually, you know what, why don't we take notes in the irregular agenda document, or I might come back and take notes afterward with the recording, rather than try to keep track of them. But the main thing I wanted to do was look at so there's the focus here is on the API. I mean, there's certain things I know you've brought up in the past, like, hey, I need a place to see the status of the individual cards and the error responses and things like that. So I'm curious to see if the way we have that in the API makes sense to you today in the prototype API. And the other thing then is to go over and try to get a better understanding of the ways in which sort of your needs from both of those standpoints of an end user and a platform administrator, kind of your needs for how you make devices available, how you can request devices, the flexibility you need there, and then as a platform administrator, how much control you need. And one of the sort of key points is, right, we have a claim and class type of thing. Class is kind of the domain of the platform administrator. Claim is the domain of the user. And one of the areas that I'm struggling to understand or getting maybe conflicting feedback from different people is how much control belongs in each of those. And maybe it's maximal control in both, but that makes the API more complex. So that's one of the things I'd love to get your feedback on, if possible. So how would you like to start? I can show you what I have. I think the easiest way to start is probably for me to show you some of the examples. If you, I know you said you were going to see if you could have time to look at them. I don't know if you did, but
yeah, I did.
Okay, then I'll let you guide a little more and ask you where you'd like to start, or if there are things that caught your eye. Otherwise, I can go with questions.
Yeah, so as this is public information, we were playing with the classic DRA, and we had this Insta Slice controller which we presented in KubeCon. And one of the interesting things there for us is having an ability to pack inference workloads on a GPU. So in the classic DRA model, what you used to happen is you take a claim that acquires a GPU with a quantity in it, like can say, let's say, give me one A100 GPU, and then the subsequent workloads will get that parent claim, and on that parent GPU allocate mixed slices. So in the current model, how do you achieve a packing scenario on a single GPU?
Okay, so that's a great question. So what we have, I'm going to pull up I'm going to share my screen with the shell probably. I think that will be better. All right, is that readable?
Yeah.
Okay, so in here, there's two okay, so the package API. What we talked about yesterday, or the other day, whenever it was, we talked a lot about the claim types. So the claim types intentionally are designed such that unless you really want to, you don't have to have any real understanding of the hardware. The intention is that the terminology used there is in user terms. Now we want to give control because there are people who do want that level of control. We want to make that possible, but we want ideally the system, the platform, to make the decisions based upon the user's needs on how to allocate the appropriate hardware to meet those needs without the user having to understand the details of the infrastructure. But things like MIG are captured in the capacity side of things. So in the capacity side of things, we have this concept of a device pool, which is a collection of devices. In the case of a MIG device, a pool is actually one MIG device, which has many of those partitions in it. And so the actually I'll look at the
So MIG should be a pool on a device, right? Or this MIG is they like MIGs is like pools of things on pools of devices. Like,
so let's just set aside for the moment the concept of a pool because it's still under debate whether we just put devices directly in there. But in a sense, a MIG is automatically a pool because it's a selection of devices that draw from a common set of shared um, resources. So the way, I'll show you what is, okay, two nodes, one. Okay, so here's an A100. What it would look like. This is what the driver would publish to the platform. And basically it says, okay, I have a pool. This is one, I get one of these resources for one MIG enabled GPU.
mhm,
And there's a set of resources that are shared between the MIGs. So like uh, the most important things to see here are the capacity and then these memory slices. And this is how we handle the placement-based partitioning.
mhm,
So from a scheduler point of view, a scheduler comes in and there's a list of devices that it needs to evaluate against your criteria. And when it picks one of those, it's going to pick the one. Like if you ask for 40 gigs, it's going to give you this one because it provides 40 gigs.
mhm,
But if you asked for something else, like if you asked for 5 gigs or say 4 gigs or something like that, then
mhm,
it would find this other device that that provides the that much memory. So it's a little bit hard to read the YAML, as I'm sure you're aware.
yeah,
Uh, it provides that much memory. Um, and so it would say, oh, this size MIG is satisfactory to meet your needs. So when it then gives you that MIG, what it does is it takes these resources, which you
mhm,
never see, and it pulls them out of this common pool. So what does that mean? That means that now the common pool has left, 35 gigs. And but in particular, it has pulled out memory slice 0. And memory slice 0 is used also by other MIG partitions. So those MIG partitions become unavailable too. So essentially it's fully dynamic MIG is what I'm trying to say, is that the scheduler
but
comes in,
yeah, but
evaluates.
then how do you ensure that the next workload lands on the same device?
Okay. So if you want another workload, and when you say workload, do you mean pod or what do you mean?
Yeah, pod, like, yeah, the
Okay.
next pod that comes in. I mean, because with mix fragmentation is very easy. I mean, you if I mean the slice. I mean, in this index, right, you have like 6 or 7 partitions based upon the memory slice, and whatever index you choose, that will hurt your packing ability. So let's say, I mean, there is some intelligence here that somebody does and places that slice on that index, but I want the next pod now to be closer to that index on the same device. So what tells me?
I guess
uh,
my question for you is who wants that? The end user because of some performance constraint, or the platform administrator because of cost constraints?
Platform administrator, because the admin, because of
Okay,
cost control. Yeah,
so it's a bin packing cost constraint problem.
yeah.
So the so bin packing we don't have in our initial prototyping, and probably not in 131 just to time. I don't know if you remember early on I had a drawing and I had like green, yellow, uh, blue, and red. The red was administrator ability to affect the sort of distribution of infrastructure to the end users who are making requests.
Mm-hmm.
Red section is not one we are planning on delivering in the short term, but in the long term we are. What you're telling me is that bin packing to you is really important. My assumption is, and my plan is, I'll say my plan, and that's just mine, and we haven't really talked much about it as a group, is that we would pick a strategy, probably most efficient bin packing, and that would be a fixed strategy or policy for every cluster until we get that red API, which allows a cluster platform administrator to decide. So what does that mean? How do I implement that? So each of these times that a workload, we're evaluating a claim and we're looking across that sort of field of capacity, we're actually evaluating a score for each node. And in order to score each node, we're basically evaluating all the ways in which the workload would fit on that node, and a closer fit or a consumption of resources that are already consumed will need to have a higher score. So that would be the way we would implement bin packing, so that the things that get a tighter fit, and using something that's already in use, like is a higher score. I haven't figured out how to do that yet. We haven't implemented anything like that yet. Like even the classic DRA doesn't have any scoring implemented, right?
Yeah,
So
but to summarize, like classic DRA helped me to pick a GPU, right? That the top level GPU claim, and then the MIG claim would, sort of, if I reference that top level GPU claim, all my MIG claims automatically used to go on that selected GPU. But
I
here in
see.
this model, we don't have it. The scheduler, with help of scoring, somehow will do the bin packing for me.
So yes, I think it's the answer is this is a discussion about requirements. So if you have this is one strategy for how we could solve the question you're talking about, and it
Mhm.
relies on kind of users not having to know about each other, right? Or that's a condition that we're trying to account for. Now, if you have the condition that users do know about each other, and you want to like schedule you want to schedule multiple pods to land on the same GPU,
Mhm.
not the same not the same. So again, we're well, there's multiple questions there. The first one is we do have a way. Are you still seeing my screen? I think you are,
Yeah,
right?
yeah.
Okay. We do have a way in the claims, um, to, um, let's see, which one would it be? It would be pod. Oh my goodness, I can't even remember which. There's too many things. It would be one of these, maybe this one of these probably. Or no, it's two pods. That's why. Two pods. Okay, let's see. It's one of these. So what this does is it defines a claim to get a
Mhm.
GPU, and then it defines two pods, and those two pods
You
get.
said it to get a GPU. Like, how do you know this gives me a GPU and not many GPUs?
Okay, so the claim, this is in your claim. By default, you get max devices one and request.devices one. So by default, you get one. This gives you, if I wanted more than one, my claim would look a little bit different.
Mm-hmm.
So I can control, like, well, oh, this is with config. That's the difference. Okay. If I have a like if we look at all the ones, let's look at some of these. Let's just go through a few of these to see what they look like. So this asks for, well, let me go. I'll find the one you're looking for. Here's its prioritized list. That's a fractional. Okay, here's a weird one, but kind of along the lines of what you're saying. You're asking, how do I get more than one? So this is saying basically, by default, the minimum is one, request is devices is one. So this claim says, I want between 1 and 8 GPUs. I'm willing to take fractional GPUs. That's what allow shared means. That is ones that are shared with other users that I don't even know about.
Mm-hmm.
And then this is not part of the actual API yet. It's just something I added in this example. And then, but the criteria for deciding between how many I get is that I want to cover an aggregate 128 gigs. So if you can give me one that's got 128 gigs, I'm happy. If you need to split it across two, that's fine. If you want to split it across, 8 different ones, I'm happy with that. Now I could also, because I may want more control over that, I can also do, well, you know what, I'm happy to do that, but I'm not happy to get ones that are heterogeneous. So I want them all to be the same model, right? So now this is saying, give me a set of GPUs. In aggregate, they have to have 128 gigs of RAM, and whatever set you give me has to all be the same model.
Mm-hmm.
So,
Okay.
so that it doesn't do what now. If you really wanted to get, you could actually say, give me it the same. Give them all to me on the same card, right? Which I don't think we have an attribute name for. We're gonna have to come up with these, but like hardware device name or something. So this would say, obviously, I don't know how big these things get, but if you wanted to split it across multiple MIG partitions, but you wanted to make sure they were all on the same physical card, you could also do that with a match attribute here.
Mm-hmm.
So those are kind of like the way that I'm sort of the way that this is kind of designed is you create selection criteria to decide whether you want one or a set, and like evaluate whether that one meets some set of criteria. And then if you're selecting a set, be it to satisfy a single claim or a set of or multiple claims, you can apply an additional constraint on that set to require some sort of consistency between the elements of that set.
Yeah. So thank you for that. So when you say match attributes, believe you are saying constraints. So to apply those constraints, somebody should expose such node topology information, right? So
That's
where
correct.
does that exist?
So back in the pool model, so if we go look at the pools, we can look at the okay. You see these attributes. So you can have things like vendor model, and the idea is that we will have also things like PCIe root and NUMA, and we're going to have to come up with the things that they are. This is expressive enough for what I would call simple internode topology. So it's like you're not going to do like if you look at there's an algorithm that Kevin shared with me for NVIDIA GPU allocation that looks at like number of NVLink hops and all kinds of things like that. You're probably not going to be able to do that level of sophisticated algorithm through this model. I'm sure you're not going to be able to. What you can do are simple matches. You can say that all of these things need to be on the same PCIe root. All these things need to be in the same NUMA node. But beyond that, we don't have a solution at this time.
Mm-hmm. Okay. All right. Yeah. Yep. Thank you.
Yeah. So what I gathered because is okay. You had asked about so bin packing. I
So,
guess
so one more question on the
yeah.
attributes. So if you have like, multiple NIC server, right? So will this attribute express which GPUs are closer to which NIC or which kind of NIC?
So they will for if those are. This is where we have to decide like on those attribute names. So NICs are going to be handled by a different vendor's driver than the GPUs. So that those vendors have to agree on those attributes. So you can specify. Um, you can specify. Here's an example of one with a NIC 2. Here's one of my most complicated examples. So basically, this is saying I want an SRIOV NIC. I want a PF, whatever that means to that vendor. We could theoretically do a whole card, which might have multiple PFs too. Um, and then I want one of these things. I either want a model 4000, I want two model 2000s, or I want four model 1000s. So in the end, I end up with two devices, a NIC and a GPU. And whatever NIC and GPU I get, I want them to be on the same PCI root. I can express all of this in the claim, and I can express all of this in the capacity side of the model. Um, and successfully resolve this claim with the current prototype.
Mm-hmm. Okay.
But it requires that the vendor of the NIC and the vendor of the GPU both publish an attribute called PCIe root that tells them which root complex you're on. So we have to come to some agreement about that common set of well-known attributes.
Okay. Okay.
Now,
And
go
these
ahead.
classes here, like one of all of them are the same. So is the intent like a single class will represent different types of fusers? Like, I mean, here I see 4,000, 2,000, and 1,000.
It's up to, so the administrator can create classes that have constraints on top of those attributes. So I also have a class here called example.com fooser 1000. So I could have used this class instead and left out the constraint, and that would have been fine. It's equivalent. So the class has, so this is a question I opened with, which is like, what things need to be in the hand of the administrator and what things need to be in the hand of the user. So like the class has very limited expressibility. The class basically contains driver, which is required, well, mostly required. Driver and constraints and a set of config. And so it doesn't have these one-of constructs. It doesn't have requests where you can say this much memory and whether you want to split it across multiple devices or not. It doesn't. It doesn't control the count of devices as this prototype is written today. The question is that something administrators would want to do, or is that going to just lead to a proliferation of zillions of classes? Like these are kind of some of the questions we have.
Mm-hmm. Okay.
So we're putting more on the claim side than the class side right now.
Okay. Yeah, I guess this is complicated in itself, but I mean those are the basic questions that I had from the API terms.
Okay.
I mean, the questions that you answered for me is the scheduler will be in charge of somehow picking up the right GPU and packing. Then for the other question was about multiple NICs and the match attributes or whatever you showed will help in exposing those information so that we can assign that a particular MIG which is closer to a subset of a GPUs on a dual socket node probably. Um,
Yeah. So let me ask a question. So one of the things, so so this model allows some limited control, but one of the things as a cloud provider, and we design node shapes, like we may want to say this GPU goes with this specific NIC. And the thing is that that we're a different party there. We're not the ones, we didn't write the driver for the GPU, and we didn't necessarily write the driver for the NIC either. So as a cloud provider, we need a way to actually create a sort of molecule or composition of multiple devices and say that you can't get one of these independently. If you get one, you get the whole. We haven't figured that out yet. It's something we need to figure out in that. So there's a couple of big open questions on the capacity model side. We have an MD with a whole bunch of open questions, which you're welcome to peruse if you want. That's an area. Oh, good, Kevin joined. So we haven't figured out how to capture what I just stated yet. And it sounds like that's a little bit is that what you're asking for? Are you really, or is the closeness constraint good enough?
I mean, for us, it's all about, I mean, for everybody, probably, it's about AI models performance, right? It's a one ball game when you do training versus a different ball game, you do inference. And specifically for training, it becomes important what type of NIC device you choose, whether, I don't know, IDMA, Rocky, or simple TCP, right? Your training impacts. So that choosing the right NIC for the right subset of GPUs becomes important in that scenario when your training runs for months, I guess. Yeah.
Yeah, I
Right.
think if I can jump in real quick.
Sure, please.
Yeah, so in classic DRA, the one that I know you guys have been familiar with up until now, the plan we had for doing this was basically building your own kind of meta controller for the DRA driver that knew how to allocate resources of different types, and then you, as the vendor who knows that you want to bundle these two things together, you would write your own controller for how to do this bundling. You'd deploy that on your cluster, and then you'd request a claim for this specific type that knew how to do this bundling together, right? But it's very cumbersome because it requires you to write your own controller to do this pairing, right? And so what John's tried to come up with here is a way to do this in a more generalized way based on what he's called match attributes, which allows you to say, okay, well, the thing that I really care about, how do I join a NIC to a GPU? Typically, the two that you want to join together are on the same PCIe route of the PCIe bus, right? And so if there's a way for me in my GPU attributes to list that this is the name of my PCIe root complex, and in my network cards that I'm potentially allocating, here's the attribute that says that this is the PCIe root complex that I'm on. And then when you create one of these claims, you list two different devices that you want to be allocated as part of that claim, and you place a match attribute on them, saying that, you know, this GPU has to have I want to match on the attribute of this field called PCIe root complex, and then that will guarantee that when you're given a GPU, this field name matches on the same PCIe root complex that your networking card is coming from, and you still get all the advantages of, I can put my own constraints in for what type of GPU I want, I can put my own constraints in for what type of NIC that I want, but when they get allocated, they will always match on this one attribute, so you know that they're aligned.
Okay.
I think, John, that's what you were. I jumped in late, so I just wanted to make sure that this.
No. That's exactly right, and that's how it's. The point I was making, or the question I was asking is, so that's the current prototype, how it solves that problem, and I'm seeing, looking at our point of view as a cloud provider, and we create very sort of specific node shapes that we may want to associate 2 or even 3 devices together as a unit. And it looks a little bit more like what Kevin was just describing as far as those other drivers, but I don't want us to have to write a driver every time we want to do that in some way. So I was kind of asking the question whether you, as an end user, care about any of that, or really as an end user, it's really, I mean, it's about getting your performance, right? And so,
I think what John's asking is, do you want the cloud provider to do this for you, or are you comfortable writing this in your claim yourself to do that association? Or maybe that's not what you're saying, but that's also an important.
That's part of what I'm saying.
Maybe.
Absolutely. No, that's a great phrasing of it. And I mean, we might need both, but I'm trying to see, is there another need surfacing here where we can create a composition of several devices and not, the question is whether we expose the devices independently or not. So do we have, when we have independent authors writing independent drivers, we have little choice but to expose them independently unless we provide some framework on the driver side or in the capacity model side for another third party, like the node, the node team that's building that shaped node, to kind of inject some additional constraints and say this device goes with this device, and you can't get one without the other. Like, and that might be not a need from an end user point of view, right? That may be just me as a cloud provider. We have this need because we don't want you independently using these things because it could like be very weak. So like, I'm just trying to suss out what your thoughts are on that.
My vote is to expose this quote unquote topology information, and then I consider this as a super user or advanced user case, and then let him do something with that. But a normal user that is probably running 2 or 4 GPU job may not need such high speed interconnects. But if you go on thousands of GPUs, you definitely need to know more about this. Is my thinking on this.
Okay. And then the question is, and we're stretching into the time for our next call.
Is it the same Zoom?
It's the same Zoom. I was gonna stop and start it so I get different recordings, but I'm not gonna bother. Do we have Andrew? Yeah, Andrew's here. Well, so we'll shift in a moment over towards Andrew's topics, but I wanted to ask one last question. So you say this is an advanced user case. My question is it still a user case? That is, this is getting back to this question. Right now, the class is fairly simple, and the claim is fairly complex. And, in an ideal world, we would only need complexity in one of those places. And I'm trying to suss out, we believe probably the claim, if we only put it in one place, it's the claim, like what we have now. But do we also need the complexity in the class? Would you instead, because it's an advanced user, have some advanced user craft a class that does this and then they distribute it to other users to use? Or is it like so bespoke to the user that that's a useless approach?
Yeah, and by user, we mean workload deployer.
Workload deployer, workload author, yes.
So I think usually our users write PyTorch algorithms, and they know what kind of topology they need. So it might be good if they can create a class, submit it to some platform admin where he saves that class, and then maybe reuse it to the other users that they want to run the same kind of jobs.
So it's like saying, here's this workload, or I don't know, here's this workload that I have, and it's optimized to run with these properties. So let me create a class for that so that you can distribute that around potentially with the workload and say, hey, admins, install this class because I've crafted that as the actual workload implementer, not the deployer, but the implementer, knowing that it'll run best in this kind of setup. And then someone that wants to deploy it just runs the workload. The alternative to that, which we've seen actually happening here at NVIDIA already, actually is, a lot of these workloads end up being bundled inside Helm charts. And so, the people that are crafting the applications themselves, they take the workloads they want to run, they build a Helm chart around it, and then along with what they're going to deploy as the workload, they're also deploying the claims that they need to grab a reference to. So whether it's a claim or a class, it makes it harder it makes it a little bit harder to be the claim, or sorry, to be a class if they don't have the permissions to actually install the class. Yeah.
So what we do have is a third possible concept. So in the current 130 DRA, and I'm sorry, Andrew, I have all day. I can schedule as many meetings as we want. But so the other the other concept we have today in 130 DRA that's not in the prototype because we're trying to reduce the number of top-level objects is the idea of a claim template. We just reuse a claim as a claim template, So the difference between those two is that the templates are namespaced and the classes aren't, and the templates as claims are fully expressive. So we might, what I'm poking at here is that we might have a use for some sort of shared claim template concept. I mean, I don't think we'd want to make it cluster scoped. So anyway, I think we can defer this topic now, but it sounds like you see a use case for advanced users creating sort of bespoke complex sets of claims that can then be reused by others. And we should think about whether that needs support in the API or whether simply here's a set of claim templates that people can reuse is sufficient. That's the point I'm getting to.
Mm-hmm. Okay.
Okay. Awesome, man. Thank you, Abhishek. So I had booked half an hour for each of these topics. One was this end user topic, and then the other was Andrew was asking on Slack about some specific questions about how, in particular, prioritized lists work. But I think there's probably other details in there. So Andrew, if you want to speak up and sort of give an overview of exactly how you're using things now in DRA, and then what sort of requirements you would have, and we can see whether or not we can satisfy them with the existing prototype and et cetera.
Yeah. So I guess a basic background is we are using, essentially we've extended the current NVIDIA DRA driver, and we added in like our own version of like oversubscription to it. And how we're doing that is essentially adding more data to the CRD that we say like this claim is in use, or it's, you know, it's idling, and we can, you know, swap out that workload. And then I guess, yeah, the issue, or what we'd prefer, I guess, is if we don't have to maintain, especially the controller, because it's like we've only made very few changes to the scheduling, where we, you know, basically are just looking for GPUs that fit, that have, like, you know, they can have this workload that doesn't necessarily need the requirements of like you know, it doesn't need to be or it can be interrupted essentially. And then on the driver side, we have a lot more stuff where we've added in, you know, our kind of all of our logic to handle the oversubscription.
So let me just ask a few questions if you don't mind.
Mhm.
So you say whether it's interruptible. So this is like a priority requirement. So this is like we have certain workloads that are higher priority than others. We have a limited number of GPUs available. We want to boot this one off. How is that preemption managed from the point of view of, do you just kill it? Do you somehow preserve state? Do you?
Yeah.
Okay.
So right now we're not actually doing any eviction or anything. We're like storing the state from memory and copying it all off, and then swapping in the new workload. When, you know, this is when essentially our monitoring determines that there's nothing happening on the GPU. So then, yeah, we block, you know, we intercept all the CUDA calls and we block them for the one workload until, you know, until it starts making requests again, and then we swap everything back in. So they're both running in that sense, and yeah.
I see.
Okay, so
You're interposing on the CUDA API, and then you're basically just blocking it. But from the perspective of the pod that's running, it's still running. It thinks it's making progress, but it's actually just blocked, and the other one's running at that point in time.
Yeah. Mm.
Interesting. Okay.
Yes.
Yeah, this is sorry guys, Andrew.
Oh, yeah.
This is Yuwen. I work with Andrew. In terms of John mentioned the priority scheduling for this GPU subscription. This is one feature for future work. We just have not started this feature yet, but in the future, there will be a part of policy controlled access or GPU sharing would be one of it. Just in case this will become over some future popular scenario like that, use cases.
Yeah, I
So
think that
so the term GPU sharing is very overloaded. But I'd want to understand exactly what you mean by that. At least the way that NVIDIA has been thinking about the whole sharing problem and the way that if you extended our driver, you know what we've already done there is that most sharing, or at least all the sharing that we implemented so far is very user driven, right? The idea is you create a claim, and once that claim's there, now workloads can all decide, do I want to share access to that claim by just having multiple workloads point to it? And if you don't do anything special and multiple workloads point to it, you're just going to get the CUDA time slicing to come, time slice that out for you. If you if you say that you want it to be shared by MPS, an MPS server gets started up, and you do some space partitioning on it, and that's how it gets shared amongst these clients. But it sounds like what you guys want, and I think, John, your terminology for this was platform managed sharing, and that you can have multiple workloads that there's oversubscribed access to the GPUs that I, as the user, don't need to direct myself. I don't actively create a claim. I don't actively point things at it. There's just some amount of oversubscribed GPUs out there, and my workloads just are able to get independent claims to them. And then something under the hood will make sure that the sharing kind of happens automatically for you. Yeah, I had until now, I had been avoiding that use case, thinking that most people didn't actually want that. What they really wanted was this more controlled GPU sharing, because the way we get oversubscribed GPU sharing today in the existing device plugin is that we just advertise more than one of the same device, right? And then basically you have no control at all. It's just whatever the scheduler happens to give you, that's what you run on. But I guess in your model, you do have some control over this, because as the claim request comes in, you kind of decide on the fly, how am I going to divvy these things out? Which is different than I've been thinking. Yeah, go ahead.
I think one of the things is like we have a fixed number of GPUs too, so we're not like scaling out, when more workload comes in. And also if there's work running, we won't be like, we determine that we won't want to schedule stuff when we know that stuff is actually running. So we'll just leave the like pod pending or whatever until it can be scheduled.
So I have some thoughts, but Abhishek's had his hand up for a while.
Yep.
You're on mute.
Yeah.
Sorry, a question to Andrew is, do you use like MIG GPUs, or you use the whole GPUs in your strategy currently?
Yeah, so currently we're targeting full, like essentially large models that have like that'll use the full GPU. If we can determine that the workload is smaller, then we can split. But we're mostly targeting for full GPU like memory. Yeah.
Okay, it would be interesting to know, as your model probably gets smaller, and if you start using MIG, then A is how do you avoid fragmentation, and then B is what even we are thinking over here is how do you do preemption? Because preemption is not evicting a pod, but now you have to understand the GPU geometry. Like, these 4 1G partitions have to be eliminated contiguously for the next 4G partition to come in, and it kind of makes things more complicated.
Yeah, I think that's why right now we're only focusing on the like large models and the full memory. We haven't actually updated the MIG code really yet. So yeah, if people schedule MIGs, like if they request a MIG, it's only if it would not go through our oversubscription code. Yeah.
Okay.
Okay, so a few comments and thoughts and questions. I think what Kevin said hit a lot of the points, but like the model that we've model that we're testing out here with the prototype has a few different concepts around sharing, and I'm trying to evaluate whether some of them are overkill or they should wait for the future till we know more, or whether people have a real need for them right now. So generally speaking, like Kevin said, we can classify sharing the resource as either user controlled or user mediated or managed, and platform mediated. So the user mediated case is what you create a single claim and then you point multiple pods at that claim. That's supported in the prototype that we've talked about. That requires the users to kind of know about each other. And it's a more controlled version of what happens today in the device plugin, where you advertise the same device more than once. So, well, actually, it's not. It's actually, I'm sorry, take that back, roll that back. I didn't say it. So that's the user mediated one. It gives you control as the user, but users have to be talking to each other and cooperating, and permissions issues and whatnot. They have to be in the same namespace, because all this stuff's namespaced. Then there's the platform mediated one. So the simple version of that is what we do today in the device plugin. You advertise the same device 2 times, 3 times, 4 times, and other random pods can come along and they can consume one of those, but you have like zero control over it, and it may do things you don't really want it to do. In the prototype here, we do have platform mediated sharing. In the case, like, okay, there's two tiers we can go, right? There's MIGs themselves, partitions, from the point of view of the scheduler, just look like other devices. So it doesn't differentiate. I mean, you'll have an attribute on it that tells you which device it came. So if you wanted to align things on the same one, you could. But from a platform perspective, there's no need for the platform to understand the concept of sharing, because it's still not sharing. It's still giving you a whole device or not giving you the device. Where we get sharing or fractional GPU is when you start to say things like the one I was showing a minute ago, which is I'm not asking for a fixed number of devices. I'm asking for some arbitrary number of devices. And I have how do I decide? Well, I have to have some other constraint. The one that I've heard from people is memory. I need enough memory to cover my use case. And at that point, that's when we need this platform mediated sharing, and where we would actually give you could still do that with whole GPUs. Actually, you could still do that with whole GPUs, but if you want to get a little more granular, you can also include the concept of sharing. And that's so that question of that sharing, where I guess you'd call
John,
it.
I think Andrew's, it sounds like, from what I understood, Andrew's use case is slightly different.
Okay.
He wants the full memory, but what he wants to be able to do is say, this workload that's running there isn't consuming the GPU all the time. He wants a way to basically have that be interrupted and then run some other workload for a while, which also has access to the full amount of memory there. And then basically do CUDA time slicing, but cooperatively. So it's not on a time slice, it's on an interrupt driven, okay, now I want to give this workload access. Okay, that one's idled, cool, I'm going to take it off, and now I'm going to give a different one access. Which I don't see how to solve in our model. That's something we need to do at the CUDA level, I feel like.
It's not something there's the only other place I've heard us as a community trying to solve that problem is in Q, at the sort of very high, not this level of like preemption in what you're doing, but more like, oh, there's a bunch of GPUs available in this cluster, and I've got 4 workloads, and I'm gonna hold one until this one's done. It's not preemption, but it's time shifting of workloads. So that's what we share in space, and all of this model that we've been talking about in this working group is around sharing in space, not sharing in time. I think it's a super interesting and useful thing, but I agree, Kevin, I don't see.
Yeah, one thing I will point out is that MPS is currently planning to design something like what I just described. So up until now, MPS has been designed to do space partitioning, basically, right? You can say what percentage of the compute and what percentage of the memory do you want to use on a GPU for any given workload. And they're currently expanding their scope of functionality to also provide something like this. I don't know what the timeline is on it, but we've had multiple people ask us for support for this. And the layer that we decided to implement support for this isn't all the way at the CUDA layer, but instead inside of MPS. So yeah, it'd be good to keep connected on this because, I don't know, correct me if I'm wrong, this is the level of oversubscription that you want, and you probably don't want to have to continue in the long term to have to maintain this CUDA whatever the word is, where you
Intercepting, yeah.
Intercepting the CUDA calls.
Yes, I think yeah, I like Kevin a summary of this and also part of John's as well. I like the term you guys introduced, the platform mediated sharing or oversubscription, this kind of term. I like that. And also, Kevin, you mentioned in some roadmap in Intel that it can be eventually to be expanded MIPS support for this kind of scenario. Actually, a scenario is very simple, actually. You think about, let's say you have limited number of GPUs. Think, for example, only one GPU available. You have two jobs. One is the training job and one is the inferencing job, which we think in most of cases, we take the inference job as a more priority. So we have these, both of them can share in one GPU, and we can serve the inference, especially with the burst.
Whenever
and
the
then
inference job has, whenever the inference job has something to do, you run it,
exactly.
and
We switch over the training, which take days or whatever time. This is, I think, the particular use cases, or we have the as a warm start because we preserve the GPU state as a warm start for a faster switch into an inferencing mode. I think this both this basic, very simple, very common use cases that why we try to support. Right now, I think we don't have a deep interaction with the lower levels technology stuff as you guys did, so we have to do it in the platform level. But as you mentioned, if we have roadmap support as this device or even lower level, yeah, I mean the CUDA level or even lower, that'd be great. But for now, we are seeking recommendation or comments on this approach from you guys.
Yeah, I guess. Oh, also in terms of the DRA side, so the state that we store is not much extra than like what NVIDIA is already storing in the CRD. We just have a map of like which claims are currently active and not active. So
based on which workload you're actually running on a given GPU at a given time. Yeah.
So that then in the scheduling piece, like all we do is check, do we have enough GPUs that are not, referenced by active claims that can be, fulfill the new claim, right? So that's what I was saying. Like, oh, go ahead.
Active, sorry, Abhishek, but active, I mean, you're oversubscribing. So, like, at scheduling time, you're pointing it at a particular, you have some sort of webhook or something that points it at a particular claim. But once it's pointed at that claim, you can't change it, right? Like, you're not moving things around.
So I think because he's using classic DRA, he can
Oh,
do
yeah.
whatever he wants. He can do whatever he wants in his scheduler, in the controller piece of the driver. And so a user creates a claim. When the allocation code inside the driver sees that, he's able to decide on the fly whether he wants to oversubscribe the GPU or not. And he uses this information about what's active and what's not to make that decision. So he might oversubscribe it or he might not. It's up to that allocation.
Yeah, exactly.
Like a GPU that's claimed but not doing anything based on your monitoring, you may not take a completely empty one. You may stick it on that one or something.
Yeah, exactly. Yeah.
Okay. But it's still at scheduling time. It's not. This isn't like active rebalancing, right? This is like you make that decision and it's done, right? You'd have to.
Yeah. So once the work is assigned to a GPU, like the claim is assigned, then that work will always be on that GPU right now. We haven't
Well,
done any
Kubernetes is
like
not political rest,
cross.
right? Like,
Yeah.
I mean, in theory, you could make it more generic. If you didn't assign it an actual GPU, but like some kind of arbitrary ID, and then you down at the driver level shifted these things around. Or
Mhm.
the
You're
plugin
kind of
level.
replacing big chunks of K8s for there.
Yeah, that's right. That's the part of a future planning work for that feature. As you can see, thank you. You think that we are thinking on the same direction for the future. Good. No.
Yeah. So I guess the two concerns with the current thing that I had was like, yeah, if we could do that, if I mean the rules right now for our scheduling are very basic. So we don't need any, like, we're not calling out to like any third parties right now, or like, third party service in our cluster right now. But if we can, like, have some sort of prioritized list of rules that we can either base on the device class or at the, I don't know if we need to check at the claim level, because if we move the information to the device of whether a claim is currently using it or not, rather than check every other claim, then I feel like we can still get the same scheduling we currently have. Instead of looking at claim level, we'll look at the device level and say whether it's being used or not. Yeah.
So you would update what we call in our current NVIDIA driver, it's called the NAS, the node allocation state object. But the equivalent of that in the new model, let's not talk about John's model for a second. Let's talk about the structured parameters model we have in 130. That would be the resource slice. And what it sounds like you're proposing is that you would continuously be updating that resource slice with extra information about whether it's active or not. And then at any point in time, when the scheduler goes to make his decision, he would have a snapshot of that at that instant, whether it was active or not, and then he could make his decision based on that somehow.
Yeah.
So that's what I was thinking about for, I guess, if we can eliminate our kind of, controller code, that's nice. And then the other thing is, right now, like, we have other components that we're launching alongside the driver, but ideally we'd be able to just launch them like as a daemon set, right? But because they need the GPU, we're actually having to launch them on the host and do like host IPC stuff, because we can't give them the GPU and then schedule other things, right? Yeah.
Right. These are monitoring type workloads.
Well, so one is like our memory manager, and one is the monitoring to get all the stats.
Yeah, so
they don't consume the GPU.
Yeah. So in our current DRA driver, I guess we haven't implemented on a branch. We haven't pushed it to main yet. But there's this notion of what we call management containers, which, at least in classic DRA, the way we implemented this is that basically there's a different claim parameters object type. So right now we've got GPU claim parameters, we've got MIG claim parameters, and there's a new one called, I forget exactly what it's called, but it's like management GPU claim parameters. And if you, and then you have, your selection criteria about which ones you want to get access to. It might be all of the GPUs, it might be just a subset of them, whatever. You have the same selection constraints. But the point being that when you get access to one of these, or when you request access to that, when our allocator code in the controller gives you access to those, it doesn't mark them as used. And so you basically get access to all of the GPUs without having them allocated. And the way we protect against everyone just doing this is that in order to actually create a claim that references one of these claim parameters objects, you have to have a specific annotation on your namespace. So only if you're in this namespace with this specific annotation can you create these management style claims. And one of the fields that we have in there I think at the moment is the node name. So you can actually precisely control which node this goes on. Or if you do it inside a daemon set, it would be whatever node you happen to land on. This is the GPUs that you get access to based on your selector. And so that's how we solve this problem for these management containers in classic DRA. Now, all this goes away, even structured parameters, you can't quite do things this way because you don't have control anymore we don't have our own controller that can implement this to basically give you access, but not do the actually allocate them out. And so we've been iterating in this prototype and even as an extension to the structured parameters DRA that Patrick's been looking at, ways to handle this, what we call admin access or management container access to these GPUs. But it sounds like this is what you want, and you just haven't found a good way to do it yet because I guess mostly because I hadn't pushed that or merged that code into our DRA driver yet. Yeah.
Okay, so we're out of time. Abhishek has a hand up for a while, and so why don't we let him give a word? The one thing I wanted to get to, Andrew, was the way we do prioritize lists might be different than what you're talking about today, and we didn't quite cover that. But go ahead, Abhishek. I'm gonna get kicked out of this room most likely in a couple minutes.
Yeah, so I just wanted to have a comment on when we talk about this like interrupt driven MPS, does it have any implications on the current claims design that we have whenever that interrupt driven MPS comes in?
I think we have to think about that, because the current claims is about sharing in space and without oversubscription, basically, right? It allows fractional subscription in the way it's written right now, the prototypes. Like you could say, but it doesn't necessarily allow oversubscription like we do with nodes because there isn't really preemption. So it's still cooperative. Like if you've got a 64 gig GPU, you can have 8 different users ask for 8 gigs, and we would only allow those 8 because they've all asked for 8. But of course, there's no actual enforcement of that. So that's kind of the model that's in there right now. But that doesn't, and even Kubernetes itself in the requests doesn't oversubscribe generally. So I don't know. We'd have to think about what oversubscription looks like.
Okay.
I think if we have time for me to throw one more comment there.
Yeah, unless I can keep going and we're recording, but I might get kicked out. I might have to move in a minute.
Okay,
Yeah, just before we degroup, just one quick question to Kevin regarding with the support for the management container. Is there any document or design have been published out or still in your branch right now?
I think it's just still all in my branch because I was just playing around with ways to do it and make it work. I mean, in general, all of the code that's in the driver right now, I wrote it over the last couple of years, but it's still very much a POC. And you probably found bugs that I haven't even found myself yet because we haven't properly tested it. It's not a product that we're pushing out yet. And so, yeah, this was just a way to figure out how we do management containers. Because, the way we do it today in Kubernetes with our device plugin is that we basically don't use the device plugin to give us access to these GPUs, right? We have our NVIDIA Container Toolkit component, which is running on the host, and it allows a backdoor to get access to the GPUs by setting an environment variable called NVIDIA Visible Devices. So our management containers today just don't request GPUs via NVIDIA.com GPU, and instead they set an environment variable called NVIDIA Visible Devices equals all, and then they magically have access to all the GPUs. It's a very hacky backdoor, but it's something we had to put in to work around this problem where you can't do this management style access in Kubernetes today. And we obviously have ways to prevent everyone from doing that. You have to be a privileged container, and I think there's some other requirements, but we don't have a proper design doc around it. No.
Good, thank you. I think we can follow up on that part. Thank you.
Yeah. And Abhishek, the last thing, what was your question just a minute ago? I had a comment to that and I forgot.
Yeah, the implications to claim when we do interrupt-driven MPS.
Yeah. So once we have this notion of interrupt-driven, I don't think it'll, at least if claims stay the way they look today, even with structured parameters, I don't think it should impact it too much, because the only difference there will be that there's a way now via MPS indicate when you want to, yeah, I actually don't know the details. I don't want to misspeak on how this works, but basically there'll be some way for you to voluntarily give up the GPU to some other process that's running via the MPS server. And so instead of it just being purely space partitioned, you'll be able to say, okay, I'm using some portion of the GPU, but I'm willing to give up my slice right now for someone else to run there. And I don't know what the mechanism will actually look like. It'll probably need to be somehow at the CUDA level. It wouldn't be completely transparent, but I don't actually know.
Okay.
What they're thinking is there.
So if we're still, if I haven't been kicked out yet, Andrew, if you can take a look at what I just showed. So in the current prototype, what are you seeing? Shoot. I gotta find it now. In the current prototype, this is the level of sharing we have, or the level of prioritization. This is done at sort of the claim fulfillment time. So it's not like a prioritization like this preemption type model we're talking about at all. This is more like, all right, I have a set of devices out there, and I have a workload, and my workload, I know very well what types of devices I can run on. I know that I can run on a device of this model. I can run on, if I can't get one of those, then I need 2 of this other model. If I can't get 2 of those, then I need 4 of this other model. So what comes out in the end is I'm either, I'm one of those 3 scenarios, and then I have this one name, and when I share it in my pod, I just give it that name, and whatever is available at the time this pod gets executed and scheduled, in that priority order is what I'll get. That's the sort of level, and these can get as, you can put all these claims, they're full claims, so you can put all the various kind of constraints, and you can list as many one-ofs as you want in here, but that's effectively how it works. I'm not sure that that's the same thing that you're asking for or not.
Well, and this just goes like top down essentially.
Yes.
Whatever's first is higher priority than second.
That's how it works. But if you had multiple nodes, like if you step back a step and as you're evaluating this, you had multiple nodes, then you would end up, if one node had a 4,000 available and the other one had 2,000s, you'd get 2 different scores. And so the higher priority item would get a higher score. Now, what I'm hearing, what might help you is if you had some way to influence the scoring, such that the scoring could look at active operational state or current allocations. I mean, really what you want is active, like, is this thing being used or not? That could be done. I mean, the problem is active operational state changes all the time, and this decision happens once. So I'm not sure if that's a good idea to mix those 2. You could look at the oversubscription level, which, that's another option. Yeah.
Yeah, I mean, I guess the way we're currently doing it, when we switch the state in the CRD, we've already determined that it's okay to move work onto this. So as long as something's scheduled right at that time, it's fine. And it's like the only real race happens when I guess something is scheduled, like currently scheduling, and we decide that, oh no, we're actually going to do work on this right now, right?
Sure, there's a gap there that could be
yeah. So that could be like the one kind of bad case, but I don't think that's.
But are you assuming these are like one long-lived and one short-lived process? Like if you schedule something to it and it's long-lived too, will the other one ever get it back? Like, how does that?
Yeah, so we have rules for like starvation and thrashing and stuff like that prevents, once things are scheduled and prepared and everything, we'll swap them in some fashion to make sure they're equally shared.
So that's when you get down to that deeper level that this model is not addressing.
Yeah, but it doesn't really affect, that doesn't have any effect on DRA, I don't think, yeah.
Yeah, that's all
So-
done in your, no
Yeah.
matter what we do at the higher layers, that's in your kubelet plugin. So that
Mhm.
wouldn't
Right,
change.
exactly, yeah.
That's right, yeah. Schedule time and runtime, we need to do the combination of that to make decision call.
Right, you want to take the thing I'm wondering was like, you take runtime state at the time of scheduling into account in the scheduling decision.
That would be the part of the
Yeah.
terroristic issue Andrew mentioned. There is
Yeah.
would be sliding window if you didn't manage well,
Yeah,
right, or what. That could be some timing issue, conflicting schedule like that could happen. But
Yeah.
I think there should be a way to mitigate that, at least to mitigate the level, if not a completely fix the level. We just like we did a multiple scheduler approach that fell into the similar category to solve such kind of issue. So
yeah.
we just didn't implement such a thing yet, but I think it's solvable in the future.
And I think we can either on the claim or through like labels on the pod or something, we can add more information like of what type of workload the person is requesting. Like if it's going to be a training job or something that's going to run for, a week,
Right.
then they can specify that and we'll know, this is probably interruptible with, another job or something that has higher priority. So
Okay.
I don't know if that belongs in the claim or if we can just do that with, pod annotations or labels or something though.
Yeah, well, the challenge with it being a pod annotation is that, at least not natively, if you want to call it that, the kubelet plugin doesn't see what pods a claim is associated with. He just sees the claims.
Mm.
So you'd have to somehow query the pod state independently.
Yeah, I think there are lots of challenges around how we get that information. And then, so if we step back and we say, okay, we need a model that an autoscaler can consume and understand. Obviously, autoscaler is not going to think about this case, but maybe they don't have to, because in an autoscaler case, you're not dealing with oversubscription, you're dealing with producing more. And so you just kind of can ignore all this stuff probably. Like, I don't know, I have to think about that. Okay, well, we're over time. Thank you so much. This has been super helpful for me. And we are going to have another session on Monday morning around the device vendor requirements. So and so folks who are interested in that, we have folks from AWS who are going to give us, we'll talk about our capacity model. And I think is that tomorrow or is that Monday? That's tomorrow. Yeah, let me check my calendar.
Yeah, I see an invite for tomorrow. Yeah.
Okay, yeah, that's tomorrow. So we'll go more into detail on the capacity model, and this is all assuming I get called to jury duty tomorrow.
I won't be there, unfortunately, tomorrow. But
Okay, well, if I get called to jury duty, then we'll probably have to postpone that, especially if Kevin can't be here.
Patrick said he'll be here tomorrow, then, so.
Okay, that's good. That's good. So maybe we can still go forward with it, but we'll see. But anyway, thank you all, and hopefully I'll see you tomorrow.
Yep. Thank you. Bye-bye.
Oh, and John, one last thing.
Thank you, guys.
I posted something on the Slack I tried to map some of the NVIDIA stuff to this model, and I have some
Failed.
questions.
Okay, yeah, I'll take a look.
In certain ways. Actually, I still have 15 minutes if we want to talk. Maybe not on this, if we can.
Yeah, we'll end this call and I can call you back.
Okay, cool.
Thanks very much.
Bye, everyone.